empirical results. Finally, let's go empirical results. Yes, man. Finally, R, which is relevance, O, which is observation, S is the search, D was the item. What else? C was the context, D was the data set, teacher was T from D times S to R, student was something else, R was the empirical risk. Finally found all of them. What else? What else? That's what else. Alpha was the linear convex combination. Pi was the order, the rank. F was the relatability of, I don't know, the item. D to the search S. That's it. Propensity is 1 over CD propensity. Explanatory, decilized. Now I'm done. Now I'm done with the shit. Now I want to study the empirical results and discussions. Here's the end of discussion. Cheers. I'm going to make the room colder. 29 degrees centigrade. Do you hear it? Don't worry, because I'm gonna shout every word for you. Empirical results and discussions. We evaluate the performance of the proposed empirical risk estimator. Well, yeah, they proposed an empirical risk estimator because they're estimating, because we have the teacher student. Now you should see how well they did by adopting a standard supervised counterfactual training and evaluation framework on real-world user behavior data collected from online traffic of a major e-commerce platform, in the parentheses eBay. I am wondering, why don't they say eBay? We know that it is on eBay at the beginning of the, I don't know. We also report the results from an online randomized control experiment on a model trained on a distilled empirical risk result to showcase the generalization power of the proposed technique from a rigorous causal evaluation perspective. Not only it works on eBay, it works on every fucking platform because we generalized. For completeness, we also conduct offline counterfactual experiments on a standard academic data sets. What do you want, academia, motherfuckers? They did all the studies for you, generated via synthetic user behavior data generation on human judged web search data following the simulation setup and code from 8. Okay, since the focus of the paper is on the incremental value from distilled empirical risk minimization techniques to control the estimation error in LTR, which stands for learning to rank, we are oblivious to the experiment design choices related to approximation error. Do you understand related to the approximation, optimization error, and parameter estimation techniques for the observation model? This room is too hot. As such, we fixed the hypothesis, class, model, hyperparameters, training, optimization techniques, and estimated, simulated, propensitated, scored across all the estimators and all limitations, the set of baseline model accordingly, respectively, perspectively. For the synthetic dataset, we describe the details of the experiment setup only briefly. Dude, only briefly. They are, what does it say? We describe the details of the experiment setup. The experiment has a setup, and they are going to explain it and describe it only briefly, and refer to the readers. If you are a real fucking reader, you go to the site 8 for extended discussions on alternative choices, data synthetic choices, and propensity estimation techniques. For experiments on the proprietary e-commerce setting, we only report lifts compared to a standard simple baseline. Why do they do that? Why do they compare it only to a simple baseline with a focus on the choices relevant to the estimation error? Oblivious to model training are propensity estimation techniques. That's it. Simple baseline with a focus on the, you need to keep it simple so that you can focus on the choices relevant to the estimation error and keep it oblivious to model training and propensity estimation. That's what you want to do. What happened to my mouse? Do you type or no? Bitch, I'm putting energy here. Where is it? Yo. Okay, I think. Okay, let's go. Experiment set up for synthetic dataset. What is a synthetic dataset? Synthetic dataset is not a real dataset. They make it by simulation and setup. They need a setup to do an experiment. Dataset semantics. Woo! That's nice. That's nice because we want to do research, and our research, other people can do that too. Well, other people can do that because they don't have the access to the dataset. Oh, okay. Now they say you can. Look at this. This is a person who has ethics, has moral codes, and wants the knowledge to be shared with everybody. Data semantics. So if you work on a data set, you should say what is the data set so other people can verify if your research was right or wrong. Do you fucking get it? You out there, if you are doing your research, you need to share your fucking data set. Dataset semantics. We use publicly available datasets with manual relevance labels. Yahoo Web Scope 40, MSLR, like Kaggle and Insta, and synthesize user engagement labels. You see that? With a standard logging policy and user behavior generation semantic following 8M1. User behavior model. That's an important. Negin had like, when I go down the list, it takes my utility from my utility. So what is the user behavior model? Use a vanilla position bias based examination model with the observation probability of you being observed given your rank. Wow, that's pretty. I love it. I love this. Well, they simplified. They simplified. Wide. Simplified, fight. They simplified. Do you remember those curves we were talking? They say, okay, let's assume P of O given probability of being observed given the rank is 1 plus rank minus 1 over 5 to minus 2, which is a good one. It feels like something. Let me show you. This is a curve that is decreasing, and once the rank goes to higher and higher, your probability of being observed goes lower and lower. Actually, this is what I like. Also, okay, I don't know how. Yeah, this is really good. And wait, what is it? Wait a second. Once you are, one thing is being observed, one thing is being clicked on. Smash the like button or whatever. So what is happening here? Why do they observe? We had R, we had C. I don't know which one is being clicked on. ignoring the trust bias. Back to me. Ignoring the trust bias. We also use the same clipping function using 8. Clipping is different from clicking. To control the variance of the simulated click propensity. Moreover, we assume that this is beautiful, by the way. They didn't make it super complicated. Oh, this is a fucking consumer and the dough goes down the list and like they just said, okay, let's simplify the consumer's behavior and just say there is this probability of the simulated click propensities. Moreover, we assume that the parameters of the propensity model are known and need not be estimated. Since user behavior modeling or propensity estimation are not the focus of this paper. See, user behavior is not the focus of this fucking paper, so they simplify it to this user model behavior that is just a function of the rank. We avoid unnecessary comparisons with more complex techniques in the literature. I love it. I love it. Stay away from complexity as far as we can. Estimators. What is estimator? The logging policy is trained. What is logging policy? It's trained based on a standard supervised training on 1% of the training data using an empirical label distribution. So the estimators means the learning models, right? What is the logging policy? Is the data set trained based on a standard supervised training on 1% of the training data using an empirical label distribution based on the available relevance judgments. The logging policy is assumed is assumed to be deterministic. What is logging policy? Let's check ChatGPT for this. Logging policy.
A logging policy in the context of counterfactual learning to rank, LTR, is a strategy that determines how user interactions with the ranking system are recorded. The logging policy is crucial because it influences the quality and reliability of the data collected, which in turn affects the performance and accuracy of counterfactual LTR models. Here are the key components and considerations for designing an effective A logging policy in the context of counterfactual learning to rank, LTR, is a strategy that determines how user interactions with the ranking system are recorded. The logging policy is crucial because
how to record the interaction of the user with the ranking system.
It influences the quality and reliability of the data collected, which in turn affects the performance and accuracy of counterfactual LTR models. Here are the key components and considerations for designing an effective logging policy. Key components of a logging policy. Interaction data, what user interactions are recorded, example clicks, impressions, dwell time. Contextual information, what contextual information is logged alongside user interactions, example user demographics, session data, query context. Granularity, the level of detail captured in the logs, example individual clicks versus aggregated click-through rates. Sampling strategy, how user interactions are sampled and recorded, example logging all interactions versus a random sample. Bias and fairness, measures to ensure that the logging policy does not introduce biases or unfairness in the data. Privacy, ensuring that user privacy is protected and data is anonymized as necessary. Considerations for designing a logging policy. Representativeness, the logged data should be representative of the overall user population and behavior. This helps ensure that the counterfactual models trained on this data generalize well. Bias reduction, The policy should aim to minimize bias in the logged data. Bias can occur if certain items are shown more
Okay,
frequently or
no.
preferentially due
No.
to existing.
So logging is the interaction of the user with the ranking system. Whew. The logging policy is trained based on a standard supervised training on 1% of the training data using an empirical label distribution based on the available relevance judgments. The logging policy is assumed to be deterministic. The naive estimator is trained on the biased empirical click distribution without any corrections, and the IPW estimator is trained via 6 using the actual propensity scores used for data synthesis. For all distilled risk estimators, we use the same pre-trained deconfounding teacher model T1 trained based on the IPW de-biased empirical distribution via the point-wise cross-entropy loss. Okay. Discussed in 11, the KDT1 is trained via 7 and the hybrid estimator HDT1 alpha 1/2 and the doubly robust estimator. What is HD? Hibernated discrimination 3 alpha. So they are trained using the same teacher model T1 and actual synthesized propensity score values. Okay, perfect. They are just saying how to train their model. Training. Following 8 for the hypothesis class, we use MLPs. What is MLPs? NLP is non-linear programming or natural language processing. MLPs with 232 hidden layers. MLP is machine learning processors, right? 32 hidden layers. MLPs. Multi-layer perceptrons. Perfect. Multi-layer perceptrons. And adopt the standard lambda loss optimization framework to train a model on the proposed empirical resistance. N is 10 to the 6 training samples, which is 1 million, randomly sampled from synthesized data. Evaluation metrics. So they talked about their algorithm, their data sets, and what is the metrics? We use the normalized expected number of clicks as the main evaluation. Normalized expected number of clicks, click-through rate, right? Which is aligned with the training objective, specifically for a given search context S, with the candidate set DS, the expected number of clicks for a policy pi is L pi F DS T, which is the same linear cost function we had by adopting the synthesized observation probability P of observed given the rank from our which is 1 over rank to the power of 2 1 over x squared, right? Our user behavior, well, the x squared has such a slow decay. They could choose harder decays from our user behavior model as the discounted function L and IPW debias click as the relevance label RDS, and normalizing the contribution of individual context by the maximum attainable value, we get our primary metric NCTR. Moreover, by adopting the original judgment-based relevance labels as relevance labels RDS and data agnostic standard log rank discount for L, NDCG rel with respect to the user. What is NDCG rel? Non-discriminative cognitive growth, relevance. Let's see what is it. NDCG rel. Normalized discounted cumulative gain is a popular evaluation metric used in information retrieval IR and ranking tasks to measure the effectiveness of a ranked list of items. Oh, okay. So it's a metric to measure the effectiveness of a ranking of a list. NDCG accounts normalized discounted for the relevance of items and their position in the ranked list, emphasizing the importance of higher ranked items. Here, NDCG typically refers to NDCG. So for components of NDCG, relevance score, rel. Each item in the ranked list is assigned a relevance score, which indicates how relevant the item is to the query or user. Need DCG, discounted cumulative gain, measure that accumulates the relevance score of items in the ranked list. I need to have an example for this. With a discounted applied based on the position of each item. Factor reduces the contribution of lower ranked items, reflecting the idea that users are more likely to consider higher ranked items. That's true. Is it the same ranking function? IDCG is ideal discounted cumulative gain. The DCG of the ideal rank, where the item serves it as a normalization factor. Calculation of NDCG, score for a list position at position P is calculated as well. DCG of P is I up to rel I of position I, and the algorithm in denominator, discounting factor. IDCG, NDCG is DCG over IDCG. Very interesting. So wait a second. So NDCG for rank 5 in their example is 0.97. The NDCG score of approximately 0.97 indicates that the retrieved list is close to the ideal ranking in terms of relevance, and NDCG score of 1 would be a perfect ranking. That's so beautiful. So they actually have a metric. That was nice. I like these terms that I learned. Wow, just next section, experiment setup for real world data user. Damn, it's hot here, I don't want to. Experiment setup for real world user data. Okay, they have another data set which is for the real world. Previous one was based on the synthetic data. We collect the data set of around 1 million queries. Wow. Okay, because the previous one was also 1 million. From a major dude, don't say from a major account, say eBay. In 2023, with a single click event attributed to the logged SERP, oblivious to the logged policy and the post-click engagement events. Wait a second, why should it be oblivious to this? single click event. What does a single click event? Try to log the SERP. SERP is the search engine result page. Log the SERP means users with interaction with the result page. Oblivious to the logging policy. Why should it be oblivious to the logging policy? And the post-click engagement event. Okay, so it is oblivious to the post-click engagement event, meaning like if it was Amazon and the user clicked on it, they didn't go further to see if they bought the item or not, or they maybe even returned it. For training efficiency, we sampled 3 negative samples at random. 3 negative samples, what is that? At random from impressed items. What is an impressed items? Within each training SERP. What does that sentence mean? I have no idea.
Sampling negative samples is a common technique to improve training efficiency in learning to rank (LTR) systems, especially in contexts where positive samples, relevant items, are much less frequent than negative samples, non-relevant items. In the context you mentioned, you are sampling 3 negative samples at random from impressed items within each training search engine results page, SERP. Here's a detailed look at how this can be implemented and its implications. Process of sampling negative samples. Training data preparation. Positive samples, these are items that the user has interacted with, example clicked, purchased. These interactions indicate relevance. Negative samples, these are items that the user has seen, impressed, but not interacted with. These items are considered non-relevant or less relevant. Sampling negative.
Oh, negative samples are didn't trade like ignored. Impressed but not interacted with. Has seen. Oh, impressed means seen but not interacted. So the user scrolled but didn't click on them. These items are considered non-relevant or less relevant. Alright, I get it. What does he mean when he says, in the context you mentioned, you are sampling 3 negative samples at random from impressed items. From the items that has been seen, observed, 3 of them not, 3 negative samples. Okay. And 1, for example, clicked one. So impressed is O1, O equals 1. Randomly select 3 of these non-interactive as negatives. Implementation is identify positive samples, which are the ones that are seen and clicked. Once you click, you definitely see all the items in this here that user has clicked on or interacted with. Identify negative sample. Didn't interact but observed, has seen but not interacted with. Random sampling, randomly sample 3 items from the negative sample. Okay, now we have a better understanding. All the candidate items to be ranked by the candidate estimator. Estimator. The baseline model for all the reported lifts is trained on the naive estimator corresponding to observed without the bias. What is the naive estimator? IPW, inverse propensity weighting estimator, and all other estimators that rely on propensity correction. We use estimated propensities using the standard regression-based expectations maximization techniques. On a vanilla examination-based position bias, fuck off, dude. The teacher models are trained on a predictive task with a cross-entropy loss over datasets with different distributions. The deconfounding teacher T1 is trained based on the IP. So it's talking about how they set the estimator for this shit. To ensure that the relevancy of both the positive and negative items are observed, satisfying the conditions explained in section 3.2.1 counterfactual models. Binarized. Where is it? The relevance teacher T2. When did T2 show up? Is trained via expert judgments, trained on query item pair. Alright. With binarized relevance annotation. So there was a judgment that said, okay, this query and this item are relevant, but binarized, which satisfies stringent calibration properties. We are oblivious to the data pooling and training techniques used to train this teacher. The hyperparameter alpha of the hybrid estimate is optimized. Evaluations. For offline experiments, we use NCTR. What was NDCG? Non-discriminatory. Normalized discounted cumulative gain. Alright. What is NCTR? Normalized click-through rate. Woo, yes! NCTR should be normalized click-through rate. Yes! It is. With respect to IPW debiased clicks as a relevance labeled as a simple rank fit on the estimated propensity. We also use normalized discounted cumulative gain with respect to naive clicks as well. For online experiments, we report ranking efficiency metrics in terms of concentration of engagements in top slots, DCG, as well as the cumulative reward metric which are empirical research questions, results and discussions on synthetic data. On synthetic data. Wait a second. So far, one was the semantic of the data set of synthetic. One was the real world data. Now they are saying the research questions. Okay, we are about to finish, guys. Not much left. Oh, by the way, okay, at the end of the day, we want to see how much this distillation helped the learning to rank, right? Results and discussions on synthetic data. Table 1 provides an overview of what is the table 1? Performance evaluation of the candidate estimators in full ranking settings There is no display rank cutoff with known propensity using n10 to the 6 simulated retraining queries evaluated over 20 runs over the test dataset following detectable effective sizes. Okay, we have NDCG rel. So, if NDCG is closer to 1, it means that we have a better ranking, right? So why do we have Yahoo MSLR is, oh, they were the 3 data sets. All right. And NCTR was normalized click-through rate. And we have these approaches: logging, naive, IPW, KDT1, HDT1, DRT1. And we can see that, for example, logging and HDT1. Which one is their model, by the way? HDT1. So HDT1 is better on Yahoo, better on the MSLR, better on. It seems KDT1 is the best. HDT1 probably is the student which comes from KDT1, and that's why it's probably a bit less good, but it's still better than naive and IPW. Yes. And DRT1 is better than HDT1. Oh, it's better than HDT1. Yes. And actually, okay, but not better than KDT1. Oh, even better than KDT1 on normalized click-through rate. Interesting. So let's see what's up here. M.SE for evaluation metric. M specified as meta columns over the evaluation dataset. SE specified as columns. We observe across all datasets that IPW outperforms the naive, okay, and all distilled estimator outperforms HDK, DDR. What? An extended discussion on the performance of the IPW and DRT1. Interesting variance analysis. The most interesting observation is that the point-wise counterfactual click prediction teacher T1 exhibits a strong ranking performance when it is used as the only target component, which is aligned with the results from 8. What is 8, by the way? I think it's the time to check 8. Okay, that's the doubly robust estimation for correcting position bias in click feedback. That's very beautiful, actually. Where it is used as there is no meaningful heterogeneity in training data distribution across search contexts in these public datasets, and a strong ranking performance can be obtained without having to sort to list-wise modeling. No meaningful heterogeneity in training data distribution across search context. The public data set where there was no, and a strong ranking mechanism. There is barely any performance gain in using the doubly robust estimator, and we omitted doing any parameter tuning for hybrids. Counterfactual evaluation on product search data. Table 2 provides relative performance lift of the candidate estimators against a naive click model based model. Naive click model based is like 1 over rank to the power. In stark contrast. Stark contrast? What does that mean? Okay, so stark is an adjective for contrast. Stark contrast to the results on synthetic data sets, we observed that point-wise features are not very effective. That's due to heterogeneity in the training data distribution. This is because guys, respect each other. Don't say shit to each other, honestly. Just fuck up each other's brain. What is the point of it? On expert judgment significantly helps with the performance of HDT2T, signifying the importance of relevance labels for all candidate items and synergy between the relevance denotation and the Despite the theoretical appeal, the empirical performance of doubly robust estimator relies on effective assumptions on observing the relevance of the unengaged items. In fact, as demonstrated in the table, the doubly robust estimator based on the is observed only in the event of explicit user engagement phase to outperform even the IPW estimator in terms of ranking. Let's look at table 2. So that is the fucking delta, which delta but NDCG normalized the cumulative gain, but it was the discounting, distributive, whatever. Relative performance evaluation of the proposed NDCG of naive. Okay, they are comparing. Delta is probably just a difference between the naive and others. As the baseline, because we wanted to keep it simple. 90% confidence intervals based on bootstrapping on test data set of what does that mean? Bootstrapping on a test data set. Why is it the size 10 to the 5? Really? Bootstrapping on a test data set may violate your usage policy?
Bootstrapping is a powerful statistical technique that can be used to estimate the distribution of a sample statistic by resampling with replacement from the original dataset. When applied to a test dataset in machine learning or statistical analysis, bootstrapping can provide insights into the variability and reliability of model performance metrics. Here's a detailed guide on how to perform bootstrapping on a test dataset. Purpose of bootstrapping on a test dataset. Estimate confidence intervals, to estimate the confidence intervals for performance metrics like accuracy, precision, recall, etc. Assess model stability, to evaluate the stability and robustness of the model's performance. Bias and variance analysis, to analyze the bias and variance of the model's predictions. Steps to perform bootstrapping. Resampling, generate multiple bootstrap samples from the test dataset by sampling with
dude.
Bootstrapping is a powerful statistical technique that can be used to estimate the distribution of a sample statistic by resampling with replacement from the original dataset. When applied to a test dataset in machine learning or statistical analysis, bootstrapping can provide insights into the variability and reliability of model performance metrics. Here's a detailed guide on how to perform bootstrapping on a test dataset. Purpose of bootstrapping on a test dataset.
Why does it say dataset?
Intervals, to estimate the confidence intervals for performance metrics like accuracy, precision, recall, etc. Assess model stability, to evaluate the stability and robustness of the model's performance. Bias and variance analysis, to analyze the bias and variance of the model's predictions. Steps to perform bootstrapping. Resampling, generate multiple bootstrap samples from the test dataset by sampling with replacement. Model evaluation, evaluate the model on each bootstrap sample. Aggregate results,
I didn't
calculate.
get what bootstrapping is. So resampling with replacement to the original data. So that's what it is. You resample and substitute. And you can see that on NDCG, actually we have -3%. Why? Which one is better? Plus or negative? Like 3% is a lot, right? Is replaced, oh, we want to say baseline is good. No. I don't know. Hard queries with poor historic conclusion and remarks. That's the important part. Guys, good job. We finished it and now we have understanding. I mean, we didn't go into the details, which we should not. But it was good. Like now I have better, like we learned some phrases. We got what they're doing actually. We proposed an effective debiasing. So it was all about debiasing at this time because ranking has this bias for counterfactual learning to rank from observational search activity data by using distilled knowledge from a relevance teacher to inform the label distribution. For a list-wise ranking task, we established the generalization power of the proposed estimators through rigorous empirical results in offline counterfactual evaluation as well as online randomized controlled experiments on a ranking task in a major e-commerce platform. We also presented a theoretical analysis of the estimation error of the proposed estimators to justify the improved generalizations from a theoretical perspective. our contributions highlight important insights into using potential outcome modeling from the more generic perspective of knowledge destruction. Perfect. Guys, I say that's good for now. I should call my sister because she was calling me. All right.